Hey, what's up? It's Jake from Nimbus DevOps, and we're here today to talk about multiple inheritance. So, apart from composing a class using more than one base class, what's of interest here is how an attribute search is performed. So, think about it this way. So, let's take and give you a picture. So, here is a picture. So, I have an object here, right? Um, it's a shape and plotter kind of deal, and it acts as a base class for everything. Polygon, so I have shape and plotter. These are your base classes, right? Um, Polygon inherits directly from them. Regular polygon inherits from polygon, and both regular hexagon and square inherit from regular polygon. And note that shape and plotter implicitly inherit from object. So you have what is known as a diamond here. Okay. And in simpler terms, it's there's more than one path to reach a base class. So we'll see why this matters in a second. So let me take this code and I'm gonna put it into some good use here. So let's make a class called shape. All right. And I have a geometric type, and it's just going to be a generic shape. And I'm going to define the area self, and just so you know, like this acts as like a placeholder. Really, this acts as a placeholder um, for what we would call the interface. And in here, I'm going to say raise not implemented error. What the heck is that, Jake? All right, and we're going to define get geometric type self return self dot geometric type, and there you go. Okay, so let's make a plotter. So class plotter, because we had a plotter, right? Class plotter, and we'll define plot with self ratio top left, and then like I've got some really awesome plotting things that I'm not going to code right now, and then say plotting at whatever ratio, whatever uh, period dot format, and then top left ratio, whatever that is. Okay, so there's that. And then maybe after plotter, I do a class for Polygon. And now we're going to get kind of more fun. So now we can do, okay, well, it has a shape and has a plotter. So that's what you were seeing as the inheritance in the picture. So this is the base class for polygons. And I can say the geometric type is, and then we'll just say polygon. Hopefully that makes sense. And then I'll have a class regular polygon, and I can just pass polygon. And why are we doing that? Because this is a polygon, right? And then in here, I can say it has a geometric type of regular polygon. And I can even go define init self side, where self dot side equals side. How did I get two equal signs there? No one will ever know. Okay. And then we got two more. So we have our regular hexagon, which is a regular polygon, right? And our regular hexagon takes a regular polygon. Why? Because it is a regular polygon. And in here, I can say this has a geometric type of a regular polygon, a square. And if I define the area, self, I can return self.side times self.side, right? Length times width. And as my, oh, that was my square. I'm thinking ahead. I'm thinking too fast. Let's go down here. Okay, so I need a geometric type for my regular hexagon. That's what I'm doing. See what happens when I go too fast. Regular hexagon. All right, and then we need to find the area. So we'll give it self, and we are going to return 1.5 times, and then 3 to the 0.5 times self.side squared. Cool. Now I can make a class square, there we go, which takes a regular polygon. Why? Because it is a regular polygon. Yeah, geometric type is square, and then I've got my square method. Okay, so now I could say hexagon equals square 12, or regular hexagon. 12 is kind of a weird number. Let's pass regular hexagon 10. Okay, so we have a hexagon. So then we want to print the hexagon dot area. I'll call that. But we also want to print the hexagon dot get geometric type to see what kind of type it is. And then we want to say hexagon dot plot, because our plot has a method that I didn't really define. 0.13 and then 7475. Okay. So that would be plotting at 0.7475 with ratio 0.93. And I could, or yeah, whatever you want to do it. That's fine. And you could do the same thing with square. I could say square equals square 12. And then I want to print the square dot area, call that. And we also want to print square dot get geometric type and call that. And then we're going to go square dot plot and then like 0.8 75 77. Sure, why not? Oh, this should probably be in there. So in this code, the shape class has one attribute, geometric type, and two methods, area and get geometric type. It's pretty common to use a base class like shape in this example to define an interface, which is basically a set of methods for which children must provide an implementation, like a number. There are different and better ways to do this, but this is just like the simplest possible thing I could think of. We also have a plotter class, which adds the plot method, thereby providing plotting capabilities for any class that inherits from it. And of course, the plot implementation is just a dummy print in this example. I'm not actually plotting anything. But the first interesting class is the polygon, which inherits from both shape and plotter. So there are many types of polygons, one of which is the regular one, which is both like an equiangular and equilateral. So when we create regular polygon class, it inherits from polygon. For a regular polygon where all sides are equal, we can implement a simple init method, which just takes the length of a side, and we can create a regular hexagon and square classes, which inherit from regular polygon. So this structure is pretty long, but hopefully it gives you an idea like how to specifically tailor your classification of your objects when you design your code. So take a look at the last 8 lines that are here, though. When we call the area method on hexagon and square, you'll get the correct area for both because they both provide the correct implementation logic for it. And when you call get geometric type on both of them, even though it's not defined in their classes, and Python has to go all the way back up to shape to find the implementation for it, even though the implementation is provided in the shape class, self.geometric type used for the return value is correctly taken from the caller instance. The plot method, however, is also interesting because it shows you how you can enrich these objects and capabilities that they wouldn't really have any other way. It's really popular in web frameworks like Django, um, where you provide a special class and the capabilities can just you can use things right out of the box. So all you have to do is define the desired uh, method or whatever, and then um, for one of the base classes, and then you're good to go. So this is an example of multiple inheritance. It's super powerful, but it can also get really messy, as you can see here. So you need to make sure you understand what happens when you use it. And we'll do that by starting out by looking at something called method resolution order. So I'll do a whole video on that next. So if you have any questions, let me know. And if not, then I'll see you then.